So now we're going to take a look at this board. This is the Revolt V2. I'm not up on all of the differences between the Revolt V1 and V2, but one of the differences is that the Revolt V2 comes with oversized holes and it comes with these, they call them gummies. I guess they're probably silicone. Then they sit down in the hole. This is actually really clever. Big kudos, big credits to the Raceflight guys for thinking of this. I expect to see other boards ripping this off soon, and for once when the Raceflight guys say that somebody stole something from them, they'll be right. Until you guys in the comments point out that somebody did this 2 years ago, and then I have to apologize. Anyway, moving on. The nice thing about this is that unlike a washer on the underside, and even a washer on the overside, this actually has protection all the way through the hole. That's a little bit suggestive. I apologize for that. Here, let me look at the V1 Revolt right here. This is a V1. The screw is still going up through this hole. I apologize to the church ladies in the audience. This hole can still transmit vibration. The screw is touching the inside here, the inner diameter, and it can still transmit vibration to the board. And especially because the Revolt has a very, very sensitive gyro that can make a difference, where a lot of times on the less sensitive gyros it doesn't. There's actually an interesting thing going on right now, that is that one of the best running gyros is the MPU 6000, which is not the most sensitive. It can't run at 32 kilohertz and etc. And it turns out that somehow that actually works in our favor. So we've got these very clever vibration isolation gummies that we'll go ahead and install. I'm not going to show you that. You just push them through the hole. It's not rocket science. And then the next thing we're going to need to do is we're going to need to solder up our voltage here for the UARTs. So what we've got here is what's called a solder bridge or solder pads, and you're going to bridge 2 of these pads depending on what you want. So here we've got 5 volt, it says here, and here we've got 3 volt, and here we've got VCC, and you'll notice that here we've also got VCC. So we're going to choose whether we want 5 volt or 3 volts to be put, or 3.3 volts really, to be put onto the VCC pin. That's the power pin for this UART. And the reason we're going to do that is that if you have most receivers, they'll take 5 volts. But if you have a Spectrum satellite receiver, it needs 3.3 volts. 5 volts will actually burn it out. And this is a very nice thing that they've done when they designed this board, which is to allow you, and you see you've got a similar one here for the UART 3. Very, very nice. It lets you put any receiver anywhere that you might want it, and choose the voltage that it's going to receive. Now when you do this, you're definitely going to want to be careful. These are small pads and it's very easy to damage them. You may want to use a little bit of a colder iron. I'm going to go in at 750 Fahrenheit. I feel confident that actually, and I'm going to turn this sideways as well. I feel pretty confident that I'll do okay here. It is going to be hard for me to do this without getting my head into the shot though, but let's see how I do. There we go. Again, I might have made that look easy. Well, what you want to do is basically these pads are so small and so close together, you could basically just feed solder in and it'll bridge by itself. Sometimes if the pads are a little bigger or a little further apart, you might need to individually tin the pads and then sort of bridge them. But there you go. Now you've got the solder bridge set up correctly. And just on principle, since I know I'm not going to use any Spectrum satellite gear, I just don't use that. I have a Tyrannus. I'm going to go ahead and bridge the other one over to 5 volts as well. And I'll try and do it. I'm just going to hold the soldering iron tip. This is a chisel tip. I'm going to sort of hold it between the 2 pads so it's kind of touching both of them and feed solder in. And there we go. As soon as the heat gets in there, it flows and you're good to go. When you are soldering solder bridges, make absolutely sure that you never, and I mean seriously never, bridge all 3 of them. Well, I take that back. Sometimes, in rare cases, I've seen them with their design that if you bridge one way, it does one thing. If you bridge another way, it does another thing. And if you bridge all 3, it does something else. But generally, in a case like this is a binary, a mutually exclusive decision. You want either 5 volts or 3.3 volts. If you were to bridge these pads, all 3 of them, by accident, the 3.3 volt regulator would feed into the 5 volt regulator, or sorry, the other way around, and stuff would get ruined. The next thing that I would do at this point in the install, because this is a new board that I'm not familiar with, is I'm going to go find a pinout diagram of the board. And in this case, the Raceflight guys have done me one better. It's not just a pinout of the board, but it's got the whole, all these handy little motor directions and all the extra stuff. So I'm going to have this nearby, and I'm going to refer back to it as I continue the build. Normally, when using a serial receiver like SBUS, iBus, or Spectrum Satellite, you can put that receiver on any UART you want. It doesn't matter, one's as good as another. But in this case, I notice that the pad here is specifically labeled SBUS, and I think I know why that is. We can only put SBUS on UART 2. And the reason for that is that SBUS needs to be inverted. Now, on the F3 boards, and I don't know why this is, but on the F3 boards, the inversion can be handled by the hardware on the board. But in the case of F4 boards, you need an actual separate discrete inverter. So with an F3, the microprocessor itself does the inversion. At least that's how I understand it. And here, in fact, I believe this is the inverter. I'm going to guess that's what that is. And so we can only hook a SBUS receiver to this UART. We can't hook it to any other UART that we might want to put it to. So let's remember that. The receiver is going to go on UART 2. Alrighty, so I'm going to identify the board forward-facing arrow right here. I'm going to point that towards the front of my copter, which is going to be the opposite of where the battery leads come out. Oh, and by the way, I have decided that there isn't any way I can get the RROSD on this board because of the way the wires would have to pass through to get the current sensor. So no current sensor on this board, unfortunately. I'm just going to take the Revolt and I'm going to press it down and there's no threads for me to put screws on there. So that's too bad. That's really too bad. I heard someone who shall remain nameless say that with these gummies, you actually don't need screws, nuts on top of the screws, because it holds on there pretty well. And I have to say, they might be right. That is on there pretty snugly. Oh, well, I finally managed to pull it off. I still would obviously feel better if screws were on there. I wonder, oh, you know what? I got it. I've got 2 nuts on here because I need clearance from this, but with the gummy in there, that's perfect. The gummy is going to give me all of the spacing I need. Oh, yeah. Oh, perfect. Yeah, see? Perfect clearance right there. Good to go. Beautiful. And I'm going to put these nuts on just on principle. I don't want to over compress these gummies. Maybe I won't. Yeah, especially with the extra thread sticking out there. I don't think that's going anywhere. You don't want to over compress the gummies because it'll get rid of their vibration isolation characteristics, and it's just not possible to get too many threads on these nuts. They're just going to come right back off again, I anticipate. Yeah, I'm not going to do it. If that bites me, then so be it. Okay, what's next? I'm going to back up for a minute here. I realize that since I'm not putting the RROSD on, I need to go ahead and finish up with my ESC. And one of the things I need to do is to wire up the battery pad. So let's go ahead and do that. Get a little more solder on here, perhaps. Okay. And this I've tinned because it was in use before, but let's go ahead and just add a little fresh solder, get some fresh flux in there, and so on. That's not going to really work. There we go. Minus to minus and plus to plus. Let's not screw that up, shall we? Let's think about this for a second. I always say that you gotta strain relief your power lines so that they don't get pulled on the pads when the battery comes flying loose. I wonder how I'm going to accomplish that. Oh, foo-for-ah. Look what I've done. Yeah. Well, I guess the battery could go on site. The battery pads. Does the battery go on front to back? Maybe it should go on sideways. Maybe the battery should go on sideways. Maybe that's fine. Oh, well, think about it. I'm going to need a, you know what, this is going to get mighty hot and mighty uncomfortable. I'm going to need a, if you look at this joint right here, you can see that there's a little underhang where we haven't really gotten, basically this is a dry joint, I think I would call it. There's this little underhang here where the wire hasn't made good contact, the solder hasn't flowed to make a fillet to fill in the corner. So I would not call this an acceptable joint. See, it's just kind of sitting on top of the solder that was on the pad. It hasn't really flowed and become one. And the reason for that was that I didn't apply heat long enough because I was trying to record this and I wasn't looking at the joint. I couldn't really see the joint. So now I've applied heat long enough and the whole thing has flowed, just become one nice smooth blob, and that's really what we want. Okay, so now we've got the main battery voltage leads installed. And the other thing I'm going to do while I'm down here is I'm going to install a wire for VBAT monitoring to let the flight controller know what the battery voltage level is. Now, one way you've seen me do that before in my Wizard X220 video is to solder the wire on top of this lead, the positive lead and the negative lead. And the problem with that is that soldering a very small wire onto a very big wire, it can be a little tricky. It's easy to accidentally reflow this big wire and have it let go from the pad when the other one hasn't soldered. Anyway, it's a little bit tricky. And the nice thing is that this ESC, this Aikon 4-in-1 ESC, has a nice separate pad here for VBAT plus and minus. And let's just confirm that that's true with a multimeter. It seems obvious that that's the case, but let's just make sure. So I've got my multimeter set in continuity mode. And in case there's some of you out there, that's the symbol for continuity mode. In case there's some of you out there who don't know multimeters inside and out, what that means is that when there's electrical continuity between the probes, you'll get a beep. So what I'm going to do is I'm going to confirm. I'm going to touch one probe to the plus and one probe to this plus pad here, and I should get a beep. Yes, I do. So that means they have continuity. That means that this pad is also VBAT plus, and the same thing for minus, and sure enough, I do. So I've just confirmed that those pads do what I think they do. So I'm going to need some wire for that, and I like to use silicone wire as much as I can. Silicone wire is extra flexible. It uses very fine copper strands, and it's coated with silicone insulation, which is very flexible and also very nice high temperature resistance. And what I've done is I've ordered, now this came from Amazon, it's just it's an assortment of silicone wire. You can see right there, and very nice. It is, what gauge is it? Oh, it doesn't say. Does it say on the wire? Yeah, it's 22 AWG, and I think 22 AWG is a good size for signal wire and just that sort of use, general purpose use around a quadcopter. Not for serious current handling, of course, but just for general purpose use. One nice thing about silicone wire is that it's very easy to strip with your fingers. The silicone insulation is quite soft. And you know, I just tinned up the plus and the minus, but honestly, for VBAT monitoring, you really don't need a separate negative ground. It's for something like an ESC signal, which is quite high speed, has a lot of high frequency components. Some people argue that a second ground, a dedicated signal ground, is necessary. Other people argue that it's not, which is not a topic I'm going to approach right now. But for VBAT, I think it's indisputable that just one positive wire is okay, and you just use the flight controller's power ground as the ground reference. And the reason for that is that the VBAT has a low-pass filter on it in the flight controller. So any sort of high-frequency noise that leaks in is just going to get filtered out anyway. We obviously can't do that with a ESC signal, for example, because why am I having trouble here? It's because of this nut. We can't do that with an ESC signal because we need the high frequency components. That they are the signal that we're trying to get. I don't know what's going on here with this joint. This always drives me crazy, which is that designers of these boards put the silkscreen on the bottom side of the board, which means I can't easily put the board into place and then solder it up. If I want to read what the freaking pads are, I have to turn the board over. Now, granted, I could look at my pinout diagram, but yeah. So here is voltage monitoring. Here it says volt, and that takes VBAT directly. So then, I guess I'm going to solder to the bottom side of the board. Something I like to do when I'm soldering to the bottom side of a board is just take the board, let's see, this is facing forward, so flip it over. I'm just going to set it on the standoffs, and then when I'm done, I can flip it back, and I'll have a nice little hinge out of my wiring. So if I ever need to work on it, I can lift it off and flip it over again just like that in the future. Here is the volts. So I'm going to leave myself just a little extra slack here. Oh, about that much. Just so if I have to take this board off to work with it in the future, I'll have somewhere to kind of just move it slightly out of the way and set it aside. You'll notice that I'm not soldering these by putting the wire through the hole. I don't like to do that. I prefer actually the edge launch style pads, such as on the Luminaire Lux and the Radiance, for example, from Furious FPV. I always solder this way even when I'm not using that style of pad. I've never had it be an issue in terms of the security of the joint. I've never had them break off or anything like that. This is a zero stress joint, and I think it makes rework easier when I have to work on it again, desolder it, etc. I'm not trying to pull it out of the hole and clean the hole with a solder sucker, yada yada yada. I'm going to take this wire from the ESC now, and unfortunately I don't have documentation for this ESC. This is a new product. It was sent to me, and I don't have documentation for it. So I'm going to guess that what we've got here is ground, 5 volts, and motor number 1. And then these other guys here are going to be motors 2, 3, and 4. So that makes sense. It makes too much sense not to be right. So let's assume that it is. I guess the other thing that I should do is I should solder on a 12 volt header for the video transmitter.